recording is on, and do a quick screen share. I'm operating today on a limited programming system with one display, so forgive me while we get this just...
One of these days I expect to find you broadcasting from the top of a mountain, one of your hikes.
Then I will have made it. All right, so what are you looking at now? Let me try to fix that screen share. Okay, now I found it. Okay, here we go, everybody. I'm Ken Gracie. Welcome to the Propeller 2 live forum. And technically, we still have not released this product yet, but we're getting really close, although you guys have been using it for 5 years in some form or another. Today, we're talking about FlexBASIC with Eric Smith. I think he's here. Yep, I see him.
Yep, I'm here.
Hey, Eric.
Hey, Ken.
So, yeah, we've been in touch a lot this week, working with your tool and stuff, so it's been really fun. Before we let loose and let you get going, a couple of housekeeping items. So for the Europeans on here that have trouble buying our product, we have added now RS components for the Propeller line. They've been a very good distributor for us. I hope they work for all of you. And they will be coming on board with all this Propeller stuff along with the Jiki and Mauser. And if you're not satisfied with that as your European source, then keep telling us what you want. Like we could add TME if you prefer, or somebody else. But just trying to keep this relatively simple for us, of course. So other goodies that are in the works. Last week we had all the fun with the P2 Edge. So there will be more opportunities for us to take your money. And this will be one of them. This is the P2 Edge mini breakouts. This will be the cheapest way to get started with the P2 Edge. So you can just plug it in here, and we've talked about this board before, but Chip, you could just jump in. I think it is kind of what you see here. There's power supply, prop plug, put your P2 Edge in the middle, and then the sockets on the side can be used for the accessory kit or to get you to the micro E, the click boards. And this is something we're assembling, and it will be less than 10 bucks.
And that top, there's an extra 8-bit port at the top, which has all of the set of programming pin signals on it. So you can plug the wireless adapter into that.
Yeah, we're just waiting for one part on this, really. I don't know which one, but it's coming. And for those of you that really like to solder, here's the El Cheapo cheapest solution. This is like a $7 solution that consists of nothing more than the socket, the 80-pin socket, and then a little PCB, and then a couple headers, and then you could spend your day putting it together. How does that sound? Lots of enthusiasm for that.
Sounds good.
Looks risky.
More muting.
Yeah. You're doing a good job. Yeah, so get out your welder.
I'm still tripping out on your soldering iron.
Yeah. That's what it's going to feel like by the time you're done with it. So no returns on that. You're on your own with that board. Oh, so last week you guys all played along really nicely with the special offer, and boy, that was a lot of fun. And every time you pandered to us with our sales opportunities, you're just encouraging more of such behavior. And I'm really a sales guy at heart, so I love coming up with gimmicks for you. And in a 5-minute period, you bought all of our P2 Edges and our Johnny Macs. And it was great fun. Did anyone get them yet?
I got mine.
You're waiting
Right.
on my...
Okay, good. Yeah, so there was one problem. So as we were presenting this, I spoke of this part. Remember this? And I said this will be included, and we'll just put them in the box. However, while I was saying that, boxes were getting taped up and your packages were getting shipped out the door. So if you feel like this dog and you want to know where yours is, I have a way to get you yours. And it goes like this.
Go to Amazon and buy one. They're cheap.
That's one way. The problem is on Amazon, you got to buy 5 of them.
They're usable for more than one thing.
Okay, so if you want to do that, I encourage you to follow Roy's solution, because that'll be easier for all of us. However, if you really want this part and you want to get it from us, I have made a form, and this will be the easiest way for us to manage your request. Don't want to get peppered with email on this kind of stuff for $1, but we will put them in an envelope for you and send them out to you. And I will paste this link into the chat window now. If I could find the chat window, there it is. So there, you could go in there, fill out this form, and this will just drop it in a spreadsheet for me, and that way I could just give our sales staff one sheet and they'll be on their way. Okay? So, no need to feel like this dog. Before we get Eric started, there's so much cool stuff on the new Parallax website that we can't share until we release it. But one of those things is that we have 3 for the noobs, and I test all this because I'm a perpetual noob. There will be getting started tutorials for Spin2, FlexBASIC, and MicroPython. And you guys are welcome to add whatever other language you want here, and we will post them. But these just give you enough tips to make the connection, to download the software, get a blinky LED going. It tells you what platforms it'll run on, and then the results you should expect, and then where to get help if there is such help available. So we also have a getting started here for FlexBASIC, which Eric will be talking about today, I think, but it's really quite easy. I had no trouble with this. I just had to save my file with the .bas extension, then everything worked out just fine. So my big issue here is just needing examples, and I suspect there will be others in the same situation. So that's coming. And before we launch Eric, it's very important that we support Eric and anyone making a presentation here. So I'm going to paste into the chat his Patreon link so we can all give him some money to say thank you, because often people like Eric and others that do work never ask for anything, but it's important that we send them a few dollars here and there, or a lot more if you're using their efforts commercially and you're benefiting from it. Definitely give them as much as you can, because I know these software projects go on forever and there's never enough return for the developer in them.
Thank you, Ken.
You're welcome. Yeah, and of course we contribute to that, and we will keep doing that as long as we can.
Thanks.
So yeah, any other community efforts like this, I want to feature them on our new website. Like, for example, we don't have at present, Cluso's board or Peter Jakaki's board there, but when ready, if you just send us all that material, we'll just put it up there and send people wherever to buy it. If we're part of that or not doesn't really matter, but anything we want the community to know about other than just digging through forums, we will make available on our website. So any questions before we let Eric roll? Okay, then let's get basic.
Okay, so let me see if I can share my screen. Whoops. I want to share the whole screen. It doesn't seem to give me that option.
I just noticed a minute ago I had missing options too.
Portion of screen? Okay, are you seeing?
We see a big white block.
Oh boy. Okay, let me see if I can.
I saw your cursor fly by a second ago, so it's probably looking at a small portion.
Yeah, let me see if I can share
Now we
everything.
see a Hello World program.
Okay.
There we go.
All right. Okay, let's try that then. So I'll just briefly cover what FlexBASIC is. It's the basic compiler inside FlexProp. That's the new name for FlexGUI, because someone else was using FlexGUI for a computer product. It's a pretty traditional BASIC, inspired by FreeBASIC or Microsoft QuickBASIC. Is someone's
Yep, I'm going through and doing some selective muting right now.
Sounds like a dog eating.
Someone's in a dumpster.
Yeah.
So yeah, anybody feel free to unmute yourself, but I think I've just muted most of you.
Okay. So the basic compiler, like the other compilers in FlexProp, compiles to PASM code for both the P1 and P2, but I'm mostly going to be covering the P2 today because that's the new and exciting stuff. And the code is pretty efficient. You can look at the listing file. There's an option, so you can see what it's generating. So it's reasonably fast. It is bigger though than spin bytecodes. So that's the trade-off you have. On P2, it's not such a big deal where we have 512K. On P1, things can get pretty tight. It's basic, so syntax is really simple. I've tried to make it as compatible as possible with a lot of sort of traditional basics. You know, I've even compiled some really ancient like lunar landing programs from the 70s with it. That's one of the samples in FlexProp. Like any basic, it has floats and strings built right into the language, which is nice. So you can use ordinary arithmetic expressions for floats, like comparing string values. You know, if you want to see if the user typed the word hello, you can say if $x equals hello, and things like that. And because FlexProp supports Spin and C and BASIC, it's easy to integrate all the languages, and I'll show some examples of that later on. So as I've already mentioned, sorry, did someone have a question? No, okay. As I mentioned, we can have integers, strings, floats, arrays of all of those things. The easiest way to specify what type of thing you're dealing with is to put a suffix. So, you know, if you just say dimension A, that's whatever the default is, which is normally integer. There's an option to change that. But if you say $B$, the $sign indicates it's a string. C# means it's a floating point number. You can also explicitly type out, like you can say dimension A as integer, and now the variable A is an integer, or dimension B as string, C as single. This basic also has some more exotic kinds of types. You can return functions from a function, for example. It has classes, so you can make structures like in Pascal or C. And you can have pointers and lots of other things. But generally, you know, when you're starting out, integer strings and floats are plenty. It's got the usual control sort of features of a basic: for loops, do loops, while loops. For controllers, if, then else, select, and case. Subroutines and functions. Generally, you give these names with the, you know, there's advanced features, but you can still do go sub and go to with labels or line numbers. And of course, because it's for the P2 and P1, there's lots of P2 features. There's built-in pin access functions, like for setting directions of pins, finding input and output values. Convenience functions like pin low, pin high, and pin toggle. Functions for accessing the smart pins. Functions for starting up cogs, so you can run BASIC or PASM code in another cog. And you can have inline assembly, so inside functions, or global, like the spin2 DAT section. In BASIC, we call it ASM shared if it's a global thing. If it's just plain ASM, then it's inside the function. So we should, I guess, show you some of this stuff. So here's a really simple hello world. I actually extended this a little bit. All you really need is just the words print hello world. But just to show you that you can do line numbers if you want, I put in some line numbers. Wait MS waits for the number of milliseconds you specify. Oops. And of course, goto goes back to goto. So to run it, I hit compile and run. It pops up the terminal window. That may be a little bit hard to see. I don't quite know how to adjust my font on that. But it's just looping and printing hello world as you would expect, with a pause. So as you can see, getting started is really simple. As I say, I could have just done, start a new file. I could just say,
Eric, since you showed us the terminal program, does it support like tabs and carriage returns and whatever we might want to use for formatting?
yeah, it's a standard Windows ANSI terminal, so it accepts all the Windows escape codes and tabs and things like that.
Thanks.
Okay, so let's see a little bit more complicated. Some of these demos I put up on the forum in a post about FlexBASIC demos. So here's a little fancier demo, which asks for a name and responds to it. So we declare some variables using dimension, and I've just let them default because I know these are strings, so I just named them with a $sign. So they default to strings. Prints a message, asks what's your name, and reads. So the input function reads the appropriate kind of variable. In this case, it's a string. Prints back, nice to meet you. And then it checks for special name. So if you type in Ken, it'll ask if you're Ken Gracie, and then check. And you can see you can do things like left $, to pick off the first character of the string. And you can compare strings by saying if it's Y or Y, and things like that. So if we run it, just click on compile and run. Whoops, that's weird. I didn't think I edited it, but I must have. Okay, what is going on here? Demoitis, of course.
Well, you're with the forgiving group.
Yeah. Okay.
It's just the usual gremlins.
Error. Waiting for checks on that end. Okay. Let me check and see if I've got a P2 attached. Oh, maybe I need to reset my board. I think I have something flashed in my ROM, and that comes up sometimes. No. Okay, have I got an open window somewhere?
Eric, does input have a timeout value that you have to worry about?
No, it doesn't. I guess that might be a useful feature to add.
Yes, that would be useful, yes.
There we go, let's see if it... Still not picking it out. What the heck is going on here?
The Hello World program's not still running, is it?
I don't think so. Let me just scroll through my windows here. I changed my font, but that shouldn't matter. Huh? Waiting for checks on that end. This one. Oh my gosh. All right, let me just shut everything down here and start from scratch. Unplug this.
While Eric does that, I'll post a link to those who want to download FlexProp.
And all else fails, reboot.
That's about it. Let me get to my desktop here.
Eric, it probably has something to do with Zoom. I've had the same trouble.
Oh, really? It's interfering with the USB or something?
No, it's something about it watching your window. I don't know what happens, but I've had the same kinds of trouble.
Okay, close these.
So Wayne Green, yeah, what Eric said is FlexProp is compatible with the P1. So
Yes.
Yeah, it's a good question. And so one reason some people might want to use this tool, aside from basic familiarity, is it runs on Mac and Windows. And I think I even read in the setup tips for Linux users who are a little more on their own.
Okay. Is Hello World's working again?
Eric builds it on Linux.
Yes. Yeah, Linux is its native platform. And I cross-compile to Windows. Okay, well, I'm not gonna, I'm gonna move on to the next demo. I don't know what I did wrong. I think I accidentally overwrote the Hello World program that I was trying to share.
Do you want to paste the code into the chat window and someone can sort it out for us while you move on?
Yeah, I'll just show, I can quickly write a simple version of that. What's your name? And input, name, dollar.
Michael, you're saying that FlexProp runs on the Raspberry Pi as well? That's interesting because of the Linux development, I guess.
Yeah, it runs on a Pi.
Okay, so there we go. So you can just type in and we get hello, Eric. And I'm missing all that cool stuff where it checks for the name, but you can do things like if name dollar equals Ken and print. Wow. Save it, compile and run. So yeah, I think what happened there, yeah, hello Ken and wow. So I think what happened was I accidentally overwrote my file with I opened a new window and I think I saved an empty file in, and that's why it was not running. It was trying to compile an empty file. Okay. So moving on a little further to something like blinking an LED. There's not much to that either. You just put a do loop, pin high, wait, pin low, wait. I'm not even going to bother trying to run this one. It's kind of boring. And there's an example just like that up on the web page. Getting a little.
Do you have a pin float?
I don't know if I do. I can't remember. It would be easy enough to add. And you can do inline assembly, so you can always use P2 instructions.
I think pin float is defined for the other languages, so I'd be surprised if it wasn't there for BASIC.
Yeah, I think it is, but I just can't recall right at the moment. Well, under the help menu, there's basic language documentation.
Yeah, I know I use it a lot whenever I do the Charlie plexing.
Right. So if you open up the help and ask for the language, basic language, you get this web page. Don't know how well it shows up on Zoom, but it's got a listing of all the, all the different keywords and functions and stuff.
So Eric, the help file distributes with the tool, though. It's not online, right?
That's right. It's in the FlexProp. It is an HTML file. We could put it online. So it opens in a web browser. I don't see pin float here. I'll add it for the next release.
I think it would be good. I don't know if it breaks consistency with other things we do, but like we'll have the opcodes published for P2 online in a page so people can browse them. But I think it'd be helpful if you posted this and we linked to it online just to get it closer to people.
Yeah, sure. As I say, it's right there in the help menu in FlexProp as well. There's just the GUI general compiler info for all the languages, and then the 3 languages. Okay, so this sample program uses 2 cogs to blink 2 different LEDs. We declare them. The const keyword says that it's a constant, so you can't change it at all. But the compiler can be a little more efficient with constants than with variables. We declare some space for the other cog stack. So when you're running a basic or C code or spin code in another cog, it needs some working space for a stack. That's what it's declared as. Here's the subroutine that actually does the blinking, and it's the usual, sets the output pin to direction, sets the direction of the pin to be an output, sets the pin to 1, waits, sets the pin to 0, waits again. And here's how you actually launch it. I chose the keyword CPU instead of cog because at one point we were not gonna call them cogs anymore. And it's a lot like the spin cog spin function. You give it the function that you want to call along with its parameters. In this case, so it's the blinker subroutine. And LED 1 is which LED it's going to blink, and 500 is the time between blinks, and the stack to use. And it returns which cog it's going to run in. So actually we could print that. Running in cog. Oops, missed it. And so if I run this, so in cog 1, it's blinking one of these LEDs. In cog 2, it's blinking the other. I don't know if you can see them blinking there. So it's pretty easy to get code running on another. It's a lot like spin in its simplicity of running stuff on other CPUs. I was kind of inspired by spin because Chip did a really nice design on how to get code to run on other cogs. And similarly, if you wanted to run the code in BASIC, you would use ASM shared. And so I won't belabor this too much. I won't, go over too much of this, but it's basically you've got some PASM code here in the ASM shared block. It's got a label entry, and to start it up, you again use the CPU. This time you give it the label and the parameter you want to pass in the pointer A variable. And in this one, I started up 2 cogs, same kind of deal. This time it'll be cogs 1 and 2, and cog 0 will just sit here doing nothing after it prints the message. So any questions about what I've gone over so far? Like, does this kind of make sense?
So does the ASM shared section have to be before you access it in the code?
No, actually it doesn't. It could be anywhere. I generally put it at the beginning. I don't know why I got into that habit. But. And functions and subroutines can be declared in any order too. So you can write it in a top-down or bottom-up fashion, whichever you're more comfortable with.
I thank you for putting this together. I've been using it for Prop 2 work for some time on a Mac. And other than trying to get the operating system to allow me to run some of the executables, it's been very, very smooth.
Well, thank you. I'm glad it's working well for you. Yeah, I'm going to have to try to get a signing certificate for Macs as well as PCs. Once I've saved up enough from the Patreon page, maybe I can do that.
Hey, Eric, do you think there'd be much value in having a video driver with some graphics commands so that you could run video output?
Oh, sure. Well, I've actually done it with, I've used the Spin2 video drivers to run VGA from BASIC. And actually, maybe I'll show that next.
I had the same question.
Yeah.
Like, what does that look like?
What does that look
from
like?
the BASIC side?
I'll show you the spin. I'm going to skip over the next example I was going to show was a basic object, but I'll show you the spin object first.
Well, don't let our enthusiasm speed you up here.
No, it's fine. So to create a class, I used John McPhail's PRNG, jmprng.spin2, but obviously, any spin2 function object could be used here, video or audio, whatever. So to create a class, you say dimension, and then whatever you want to call the class. I just chose P for pseudo-random. So dim_p as class using, and then the file name. And actually, if you click on the file name, it opens up. And this is an unmodified copy of John's PRNG from the new object exchange. And then to use the class, it's basically the same kind of syntax as you use in Spin, p.start, and then instead of $, BASIC uses &h for hex, or you can use the C0x style. And then you can print the numbers out. I chose to print them in hex, so I used the hex $ function. And so to get, p.random fetches the random number. And John provided a truly random. These ones are pseudo-random, so they're always the same, given the same initial seed. But there's also an x-random, which is truly random. So if I run it, it shows me the pseudo-random numbers and the truly random number. And this is actually a little bit harder to see. I'm used to running everything from the command line. I should say I don't tend to use the flex prop GUI as much as I probably should. It would be easier to see if I could keep this window up, but unfortunately I can't. But if you note these numbers, you'll see if we run it again, these numbers will all stay the same, but the truly random one will differ. So if I run it again. Yeah, so the first 4 were the same, the last one's different. And I don't unfortunately have a graphics. The graphics card isn't working, so I can't show you a video demo. But in the sample code that comes with FlexProp, let's see, FlexProp samples in the MultiLanguage directory. There's a turtle demo, which uses Roger Lowe's video driver. And here, so dimvid as class using p2 video drive.spin2. And sets up a turtle program and runs it. It actually uses a C. The turtle code itself is some C code, and that's imported as a class also. So you can run that if you've got a VGA board set up. You can run that. And I can actually show you, I think, what it looks like, because it does write it to the, yes, it writes it to the PC. So let me run this. So even though I don't have a VGA plugged in, it's saving a screenshot. And that'll be in the multi-language. So it uses the same, whatever directory you were. Huh.
I see p2 screen.bmp right there in the list.
Oh yeah, there it is, yeah. And that's what you would see on your VGA screen. So,
Hey, so I have a question.
Mhm.
Is this, maybe I missed something, but was that thing sort of emulating a graphics display on the PC side?
No, it was. It just saved a bitmap file. So, as well as writing it to the VGA screen, it also dumped a BMP file. Here's where it's.
Oh,
It's
okay,
part of the C code is a function that'll save a BMP file, and I used the FlexProp has a built-in connection between the PC and the P2 so that you can send files over the serial line.
Okay.
So that's what it's done here.
Basically a screenshot of the frame buffer that would have been displayed on the VGA screen if you had a VGA screen plugged in.
Right, okay.
Exactly, yeah.
So Ken, you ought to be able to run that particular demo that he just ran with your VGA display and see it actually on the screen.
Yeah, that's what I'm going to do.
If it's plugged into the right pins, you may have to adjust. I think it's defaulting to pin 48 for the VGA.
In that code you were showing, there was a command just to draw a line, right?
And
well,
probably.
It was turtle. It's turtle.
It's the turtle graphics.
Commands. So it's
yeah.
logo. So you're basically saying move to line 2, move to line 2.
Yeah, exactly.
To draw.
Here it is right here.
But the driver underneath is just a VGA driver written by Rojlo, right?
Yeah, that's right. Exactly.
So the limitations of it for drawing to VGA would be things like lines and blocks and.
Well, the VGA is just a bitmap, so you can put anything in it. But this turtle code just has, forward, turn left. I don't remember all the code. It's turtle.c. Let's see what. So this I got from the web, and it's GPL'd, so I have to give the source away, and that's fine. It's in the distribution. Okay, the documentation isn't as nice as it could be. So there's various turtle. We start with turtle reset, turtle backup, forward, backwards, turn, strafe. There's various functions to draw polygons and lines and things.
Okay, so to know the possibilities, we dig into the turtle.c.
Yeah, yeah.
I mean, it's just a frame buffer for the VGA, so you could write whatever you want to draw into the frame buffer. So
sure, yeah.
So if somebody ported Chip's graphics code that drew into a buffer, it would be able to do all the stuff that Chip's code could do, which was like lines and boxes and circles and text and all that stuff.
Yeah, yeah. So this turtle program is glue between Rogers video class, which is in Spin 2, and that turtle class, which is in C. So it's using those two things, and it's creating the VGA buffer using Rogers Spin 2, and then it's using the C code, the turtle C code, to draw into it. But BASIC is a nice scripting language, really. So it's convenient for gluing things together like that. And you can see the general features, like the mount command is what sets up the PC, the connection to the PC. And you could save the bitmap file onto an SD card instead by changing the mount. So it still use the same file names. And then it calls into the turtle code to do the stuff. Turtle draws the little picture of the turtle.
Eric, you keep saying PC, but this works as well on any platform your tool runs, right?
I'm using PC in the generic sense, not a Windows PC, but Linux or Mac or Windows, yeah.
Okay.
The host computer.
The host computer, yeah. And I'll show you a simpler example of the...
And while you load that up, maybe it's really a question for Chip, but I feel the same as Jeff Rourke pointed out, that we could use a simple self-contained VGA DVI driver with some methods in it. And because at the moment, I think for the noob, the P1 video drivers are easier to use, right? Or more complete?
Well, the P1 is typically similar in that there's a driver that just draws the display, and then there's the graphics functions that draw into the buffer that goes on the display. And the P1, most people, or a lot of people, use the ones that I believe Chip originally wrote, but maybe have been extended, which is a bunch of graphics functions that draw to a buffer, and then you can use it with any display driver you want.
But we've not ported that, I think, right, to Spin 2 for the P2.
Well, it doesn't need to be ported to Spin 2 for Eric's stuff. Like, you could include the Spin version and call it from BASIC.
Well, except that most of the drivers use a lot of PASM.
No, I'm not talking about the driver. I'm talking about the graphics.
Oh, yeah,
the stuff that just draws into the buffer.
Oh, yes.
Which I think is mostly Spin.
Yeah. Yeah, FlexProp can compile Spin 1 as well as Spin 2.
Or P2.
It can target the P2 with Spin 1, as long as it doesn't have any PASM.
Yeah, that's right.
So you're saying you don't really need a Spin 2 video driver?
Not video driver. We're talking about
the
thing that draws to the buffer that the video driver then uses to display. There's two pieces, Ken. I think that's what you're locked up on.
Yeah.
Video driver is just drive the display from a buffer.
Yeah.
That's all it does. And then the graphics code draws into the buffer to get what you see into the buffer for the video driver to then display.
And it's
two
good
different
to keep,
pieces.
Yeah, and it's good to have those two pieces, because you might want to replace the VGA driver with an HDMI driver or an LCD driver, but leave the graphics drawing part alone, right? So it's kind of good to keep each piece separate.
I think Rayman already translated Chip's graphics spin into graphics spin 2 and is running it on the P2.
Yeah, I'm pretty sure Raymond has most of this stuff ported, because he's done a bunch of graphic stuff.
So that classical demo with all those spinning stuff is running already.
Yeah, there's several good video and graphics objects floating around. I like Rogers' VGA driver because it's very flexible. You can do a lot of stuff with that. So here's a simpler file I/O demo that just shows how you can write data to a file and read it back. That's the 07files.basic demo. Like I say, you just mount, you need a file name like /data. And then you say either VFS open host or VFS open SD card, depending on whether you want to write to the host VC or Mac or whatever it is, or whether you want to write to an SD card. But the rest of the code would be the same. So you can input, show a message, or write a new one. It checks to see if you typed S or W and calls the appropriate subroutine. If it's something else, then it says it doesn't understand. And to actually write the stuff, you use an open command, open, and the file name. The /data there is using the mount, right? So we mounted the /data directory is going to be the host in this case. So /data /message.txt is going to be the file name. So on the host, it'll just be message.txt. So we open it for input as number 2. So this is the usual kind of basic syntax for opening a file. You can say input number 2 message $, which is a string. So it reads the string from the file. And if it's not empty, it prints it. And it keeps looping as long as it's not empty. And if we never printed anything at all, it just gives you a message that it didn't find anything. And writing to the file is kind of the reverse. You say open file name for output as number 2. And you print number 2. So you can use all the usual printing. You know, you can print floating point, you can print strings, integers. There's actually a print using to format these things as well.
On your mount for your SD card there, where exactly are you writing to on the PC? Is it just the directory that you're in with the file, or?
That's right, the current directory of the whatever file you're compiling it. So it'll be alongside the 07 files.basic.
Can it do more absolute addressing?
It can do anything below that. I don't at the moment have a way to do it from the GUI. In principle, you can, with the command line tools, you could write it anywhere on the disk. That's not an option in the GUI right now. But the tool would support it.
Is it an option in the SD card?
In the SD card, yes, you could write it anywhere. It will create. You can create directories. You can make directories, and you could put it in subfolders of the SD card. Yeah.
Eric, do we have line input? I see we have input, but do we have line input?
I don't believe we do. That might be a nice thing to add.
That would be really handy for dealing with text and processing text from a file.
Yeah. Yeah, let me look into that. It would be easy to add. And you're right, it would be useful, because at the very end of this file, I've got some caveats. One is that the file functions still don't have a lot of error reporting. So that's why we do this checking for empty strings and stuff. I'm planning to add throwing of exceptions. There's already a try-catch functionality in the language. It's just these low-level functions don't throw anything yet. So I'm going to make them throw an error if you try to open a file that isn't there or something like that. And the other caveat is that commas aren't handled properly because we don't have line input. It's the input function uses commas to delimit fields. So it's really easy to parse comma separated value, CSV files. But if you actually want to deal with commas in the strings, you need to jump through some hoops, which I guess line input would let you avoid.
Are we still limited to 8.3 file specs in the in the file naming?
On the SD card, you are. On the host, you can use whatever the host's file system will accept. So that's the file IO. I think I skipped over the object test demo I was going to show, which isn't terribly exciting, but you can write classes. Not only can you write classes in Spin 2 or C, but of course you can write them in BASIC too. And to write there's a sample called p2 control board.basic for the accessory set. The methods are just to start, to set an LED on or off, or to get the value of a button, whether it's being held down or not. So basically, to write an object in BASIC, you just write a little program, and the variables that are dimensioned at top level are going to be the method variables, the member variables of the class. If you share them, it's like putting something in the DAT section of a spin file. It'll be shared amongst all the copies of the object. So if you have multiple instances, they'll all use the same array here. And the methods are just the usual. You write some subroutines like a start. It sets up the input pins. Set LED to turn an LED on or off. Read a button. I remapped the buttons using an array just because I wanted the pins to match up between the buttons and the LEDs, so that the one next to the LED is the same. For some reason they weren't. Okay, and in the class, if you've got anything outside of any functions, like this code here that's just, it's not in a subroutine or in a function, that's put into a special method called program, which is what gets run if it's a standalone object. If it's not a standalone object, if it's being used from another object, then it's put in the program method, and generally the unused method removal will get rid of that because you don't invoke it. So it's kind of convenient. You can write your methods, write some test code, and keep them all in the same file. But then when you actually go to use the file as a class, that test code won't be included by the compiler.
If you had those at the bottom there with a dim statement, would they still be gotten rid of, or would they remain like the dim integer you have at the
These
top?
ones, yeah, if they were dimmed, they would be variables of the class, so they would be accessible to the outside world. As just plain vars, though, they're local, so they will be removed. They're basically part of the program method.
So the way it's,
sorry?
So the way it's currently being done, you don't really need to worry about a public versus private declaration. Everything that's visible is going to be public in a class?
Yes, the BASIC doesn't really have any public or private notions.
But for variables, just the distinction between defining it as a var versus dim kind of gets you there.
Kind of, yeah.
But you can't do it for a method, or so to speak.
That's correct. Not yet, anyway. It actually wouldn't be hard at all to add that feature. I just haven't done it because we kind of have that for C. The C compiler in FlexProp supports a very tiny subset of C++. So it does understand public and private. So we could add those keywords to BASIC.
You keep volunteering for these things. I like it.
Well, I'm not giving you any promises or deadlines. I'm just saying it could be done.
Oh, no. I heard it from Eric. It's going to happen. Thank you.
Another difference.
That was my same question, except for at the top you put shared. Does that how does that differentiate from that in the var and the dims?
Okay, the dim shared creates, it's like static in C or C++. It's a single, or it's a single array that's shared by all of the instances of the object. So if you have, 2 or 3 of these boards plugged in, and 2 or 3 objects instantiated for them, there'll only be one copy in memory of this shared array. But the regular DIMM, like the base pin, there'll be a copy for each copy of the object. And that kind of makes sense because the base pin will be different for each board that you plugged in. So you want them different. But this map will be the same for all of them. The other difference between DIMM and var is that with DIMM, you generally say what type of variable it is, or, I mean, it will default if you put something like a $sign on the end, it'll default to a string. Var is different in that it defaults to the type of whatever you've assigned to it. You always have to initialize a var. So if I said var I equals hello, that would create a string. That would be the same as saying dim I as string, and then I equals hello. So var is kind of handy. It's a convenient shorthand for a lot of things. And you can see, the usual kinds of for loops and do loops and things that we have.
Does the compiler, once you dim something as an integer, does it force you to use integers, or does it throw errors when you use a string?
It will be an error if you use a string, yeah. No, I don't want to save any files. Got into trouble with that last time. I think that's most of what I wanted to show. I will briefly touch on some of the advanced features. Okay, so you can declare types. So you can say type int func as function, x as integer. So this is declaring that an int func is a function that takes an integer parameter and returns an integer. And now you can use this word int func just like any other type, like string or integer, byte or whatever. Here's a function that returns a function. So it takes as input an integer n and returns a new function. And that function takes x and maps it to x plus n. So you can actually, this is kind of fancy, but there are some cases where you want to, particularly like in a GUI, you might want to have functions that are callbacks. And so you might have different callbacks associated with different buttons or what have you. And you can, this notation lets you very simply write small functions in line without having to declare them. So when I call add n1, it's going to return a function that adds 1 to its input. So the function f of x will always be x plus 1. And g of x will be x plus 5. There's also something called generic functions that can take any type as input. So we write those by saying any t will be the type. The subroutine swap, so it takes an x and a y that are both type t, whatever t happens to be, it can be anything. They're passed by ref, which means they're passed by reference. If you change them, the changes are permanent. Normally variables are passed by value. So if you change them inside the subroutine, the main program doesn't see the change. But with swapping, you actually want to change them. Just like spin, it BASIC supports multiple assignments, so you can write x comma y equals y comma x to swap two variables. So it does the x equals y and the y equals x kind of simultaneously. And you can actually, so when we run this,
Eric,
hello?
in that add-in function where you're returning that algorithm inside the return statement.
Yep.
How complex can you get with that algorithm?
You can actually do anything. This is a simplified notation, and you can do stuff like print x, and then finally the return. So you can actually.
So the colon's like a statement separator or something?
Yeah, the colon's like a statement separator.
Okay, cool.
This is also a shorthand. I mean, you can actually write out, return function, blah, 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 like this whole kind of thing. So you can have a function inside a function if you want to. The shorthand is just a convenience. So you can see original results are 3, 4, and 8. And if we swap F and G, they'll be 3, 8, and 4. So 3 plus 1 and 3 plus 5. Let me get this out of the way. Let's see if, I think that print should work. Yeah, see, it's printing the values that are passed to it before actually printing the final results. So you can do pretty much anything inside the functions that come back, that are returned. So, I mean, some of this is a little esoteric, but actually, as I say, for things like GUIs, where you want to have interactive features, it's kind of nice to be able to just attach a function to a button or to a menu. And being able to treat functions, put functions into variables is very convenient for that kind of thing. And these generic functions are nice because they let you do things like creating, swap functions or min or max that can work on any variable of the appropriate, even if the types are different. So this swap function will work on anything. Now you could swap, we swapped functions, the variables were contained functions, but they could contain strings, they could contain floating point or whatever. They'll all work in swap.
Eric, I have a question.
Sure, Ken.
So yeah, you've got all these languages you can combine in some way, and Roy's kind of clarifying it a little bit, but let's say I had a driver in spin 1 for just the ping sensor, our little ultrasonic sensor, and I wanted to use it here in BASIC. What would that program would be able to talk to the spin 1 code?
Yeah, sure. It would work just like this. Instead of writing jm_prng.spin2, you would write whatever, if the sensor is called ping.spin, you would just write ping.spin.
So it needs to be in the same folder, and then I just have to use the parameters that are used in that object.
Right, right. Now again, if it's got any PASM in it, you'll have to translate the PASM. But if it's just a plain spin file, if all the code is written in spin, then the compiler can handle it.
And if there's PASM code, then it has to go from PASM P1 to PASM P2.
Right. You'd have to manually translate the PASM code. It's FlexProp isn't up to that yet.
Yeah.
It uses the file extension to figure out what kind of thing it is. So a .spin2 file is spin2. Plain.spin is spin1. .bas is basic. .c is c.
Now, so for clarification, if you're targeting the P1, then the spin 1 code with PASM doesn't need to be translated. It will just work.
Right, of course. And spin 2 code would then need possibly translation.
Right.
Yeah.
So whatever your target processor is, the PASM needs to be that processor's native.
Right.
So depends on what your project is targeting. If it's a P2 target, then obviously you have to translate P1 PASM up to P2 and vice versa.
Yeah.
You said it uses the C language as well, just the way it was the example you showed earlier. Have you played with any of the Arduino libraries for sensors?
I haven't. No, I know that Rayman has ported some C code over. I don't think it came from Arduino, but I think it came from some other place. But he's been doing some graphics demos in C.
Yeah, a lot of Arduino libraries won't work unless you also write the base Arduino set of functions that they include, like digital write, digital read, all those built-in keywords that they added for Arduino specific stuff that all the libraries then use to talk to the pins and IOs. But if we had a library of those, then most Arduino libraries C code would just run.
That's an awesome thought.
Yeah, I mean it's C, so it mostly will just work. So there's some C++ in some of the more advanced Arduino libraries that probably wouldn't work yet with Eric's compiler.
Yeah, I've only got a little tiny bit of C++ implemented. Probably not enough for very much of Arduino code.
Now, Eric, the Spin language has names for a lot of the Smart Pin settings values. A lot of names.
Yes.
Are you going to be using those names, or is that a simple file that we include somewhere? Is that your intent? Or?
You know, I honestly can't remember. Those names are all there in Spin 2. I can't remember if they're visible in BASIC or not. If
they're
they
visible
aren't,
in C.
Are they? Okay, then they're probably visible in BASIC as well. I guess they're.
Yeah, talking about like the P underscore count underscore
Correct.
I.
Correct.
Yeah, those are all available in C, so they're probably also available in BASIC.
Yeah, they're available in BASIC too. I couldn't quite remember at which layer I put those. If they're in the common or in the language specific, but I guess they're in the common.
Yeah, it's just a bunch of constant defines.
Right.
Yeah.
I'm always thinking about, as we're switching language, how much of the learning of the propeller stays with us, right? And so I'm always looking for that consistency. Likewise, you mentioned earlier that you use CPU instead of cog because there was some discussion there. Are you thinking about rolling back to cog now? Because
I think we should not call them cogs. It's always been an explanation thing that I have to do to any of my friends. Explain, they call them cogs, but what they mean is core or CPU.
And in Blockly, we use new processor, which was very well received by people.
Yeah, new processor might be even better, but.
Well, I'm seeing the tension because you're writing CPU, but then you comment cog, and so when you're trying to keep the concept around, then I'm going, why are we doing both?
Yeah, I don't know. I'm not sure what the best names would be.
So it sounds like we need something common across most of the languages then.
Yeah, it might not hurt to have. I know that in C we have a propeller2.h that defines a lot of the same names. Although they have an underscore in front.
So Lachlan pointed out MicroPython uses CPU.
The problem with saying it needs to be the same across all languages is saying then it must be cog because spin is cog. And we can't change spin 1.
Right.
I think it's better to move away from cog though, personally.
Yeah, I don't think I have a view of staying with or leaving. I think I'm more concerned of we're training users and we want them to be flexible between languages. That's why we're providing them all. And so having something that's similar that once we learn, we know what it's going to be. So there's less for us to learn as we move from language to language. Seems important.
Well, at least MicroPython and this BASIC use CPU.
Most people don't move from language to language, so I don't know if that's
Yeah.
necessarily a valid concern. There's people that do, obviously, like I am one, but a lot of people pick one language and just stick with it.
Yeah, I was going to say over our careers, I'm sure that we can no longer count languages on fingers and toes, and that's either
Yeah.
high level or assemblers. So I'm
Well,
not
one,
sure I believe in that fully, but yes, that's
And
we're
to
not
be
new
fair,
either.
all those assemblies and languages across the 4 decades of coding I've done have had me learn different terms for the same thing many times.
True.
Yes. We could certainly,
Not for a single processor, though. I think that hasn't happened.
I would beg to differ.
Really? Okay.
I know that the x86 has a number of different assembly syntaxes. Yeah.
Families. Ooh.
One thing we can do, all of these languages have a preprocessor built in, so we could certainly create a header file with pound defines in them. And
I mean, couldn't we just alias this? So let's say if you type CPO in spin, it would kind of also do a cognu. I mean, just using both.
Yeah, that's what he just said.
So
We could.
alt source will still work, and use source still write. I like CPU way more, or let's say even new processor, but that is in my opinion too long again. But CPU is basically nice, and if let's say fast spin would recognize both forms, even for spin 1, I mean, you wouldn't care.
I
like both of them, you know.
As I say, in FlexProp at least we can, pound include a file that just redefines whatever things however you want. So that wouldn't be a problem.
Yeah, there are 2 other things which I would like you to talk a little bit more about, because I think there might be a need to incorporate that with the whole debug stuff from chip. You basically changed P2 load terminal that it can also access that host file system, and you have some sort of protocol running there. And chip kind of added those debug things which then start whatever. Is there any way that both of this can get included somehow, sometime? Because both of it is really practical, having a file system and having those stupid debug screens on the same serial line. Any ideas about that?
I could generalize my program and, remove all that stuff out of the peanut, just the serial part, and even give it file IO and two-way communication, and we could have an app that would do those things. So it would just, be generic on the other end. You just send it text strings to configure it, and it would do its thing. Kind of like how it works now, but it could be broken out of the peanut program.
Yeah, it needs to get broken out of peanut anyways and put it either in prop terminal, or maybe better just put somehow into P2 loads terminal, which is already very used everywhere. How to explain? We need to get that together. The file system which Eric is using right now, it's pretty sort of and pretty nice, and already built in the loader and in the terminal, and now we have just to add your debug in there communication wise, that it also can stream through the same serial line without conflicting.
The way the file system works is that there's kind of an escape code that says everything after this is filed, is file data.
Yeah, and chip is doing basically the same with using that backtick in the serial stream to transfer the debug info.
So we could probably do something similar.
Right, and it just needs to get integrated, and chip has to at least, I mean, well, Windows binary, I don't know, Delphi code for whatever. You have to fight around that problem also, but combining those debug screens with the terminal you input would load would be perfect.
Not asking for much, Michael.
There's a lot of stuff I want to do like that. I'm just still messing around with this debug line draw. Kind of embarrassed to say so, but this thing's been eating me up for weeks, and I think I've got it. Today I got it like working perfectly, except I have a bias problem, which I can sort of solve, but it's not the right solution. So I wind up getting too thin of lines at certain angles. So I got to go at it from another approach, but I really want to get this thing done. I mean, it's looking like perfect now, but it's not. I'm solving this bias problem the wrong way at the moment. I got to figure out how to get it right. Then I'll quickly go and get the rest of it documented and wrapped up. And there's just so many things I want to do if I get this off my plate.
It'd certainly be very cool if we could, you know, put print statements in with backticks or whatever, and be able to do the graph from BASIC as well.
Oh yeah, well it's simple. I mean the whole protocol is textual and simple.
Yeah,
You know,
I like
so
that.
It can be repurposed. But I really want to get it.
Unloading is, as far as I understand, that you basically attach a preloader to your binary to load first the debug stuff into the high ROM and then relocate the other binary back to 0.
Right. Yeah, it's pretty simple. But you know, we don't even really, you don't need to be in a debug mode to send that graphical debug display data. You know, you can do that from a program. The debug thing makes it nice because it singulates messages. So if you know 8 cogs want to send something to the debug thing, it singulates their messages, whereas otherwise you'd have to come up with some kind of you'd have to use some kind of semaphore to gate who's going to send a serial message.
So without even starting in debug, I could send debug messages by sending it just through the serial port.
Yeah, it's just textual messages. There's nothing tricky about it.
Nice.
Stephen.
Yes.
You know, you were asking, I would have been so far along. I mean, I think I've spent so much time on the stupid line draw, I could have had a single step debugger working by now. But anyway, this thing's been really challenging. I mean, it sounds like a simple problem, but it's just eaten me alive for weeks. And it's the hardest thing I've done in recent memory. I mean, all this other stuff I got to do is simple.
I know how our mind gets there. I can appreciate that.
And I told you to drop it a long time ago and come back to it later. It's a cosmetic aesthetic thing that doesn't matter right now, whereas all the other stuff on your plate after it do matter right now.
Well, what I was going to tell Stephen is that he's run out of debug space. So one like really simple thing I can do is make an extra low-level debug byte, which tokenizes all those commands so that as we compile debug statements, all the keywords get reduced to a command byte and a key byte.
Nice.
And that would totally save memory.
Yep.
That would allow things to crunch down really well.
Just for background for people, we found an issue that Chip is working on where it's not quite reliable in telling you when you compile out of space. And so things just start working badly.
Oh yeah, I'm sorry, I haven't, you know, I got into that thing one day to try to figure out, I wanted to trip it so that it would give me an overflow message, but I realized because it's looking for identical messages during compilation, you can't just do 1,000 of the same message. It doesn't add, it doesn't add 1 byte to the database. So I have to do something to generate. It's trivial. I just make something that makes a bunch of strings. But anyway, I didn't finish it, but I got to find out why it's not giving a proper error when you overload it.
Right.
Okay. Let me just go back to my slides and see if I've covered everything I wanted to. I think I have. Basic objects, yeah. Spin to objects, yeah. File, advanced features, yep. I think that's pretty much all that I had to talk about. I did post a zip file with all these examples on the forums. I don't know what else to. FlexProp in general, I hope isn't too hard to use. It's not quite as nice as the Propeller tool, but it is cross-platform, and it's got, you know, lots of things. You can change the baud rate of your terminal. You can scan for, if you've got multiple things connected, you can specify which one you want to talk to. You can actually go right into TACAWS by clicking on the special. In the special menu, I've got entries for TACAWS and for prop Lisp. That's one of the samples is a simple Lisp compiler, or the P2 ROM.
Any tips on installing it?
No, just unzip it. It should be somewhere that's writable. So I usually just unzip it onto my desktop, but you know, you can put it in your documents folder or anywhere that's not in a system folder. And then just run the flexprop.exe. The first time you run it, you'll probably get a nag message saying, you know, are you sure you want to run this or something to that effect? Because
it's unsigned for that Macs, for instance.
Yeah, on the Mac, it's really nasty. On the PC, it will, if you click on the info, it will show you that it's signed by me. So it's a little bit happier, although it still nags.
The Mac is kind of entertaining because you have to get through a couple prompts of, can I delete this instead of running it? Once you get past that, you're fine.
There's a couple of hacks you can do on the Mac to get away from all that stuff.
Oh yeah, I'm not worried about that. But thank you.
Yeah, one thing I think I noted to Eric too, that the config file is stored in the application home directory, and that will cause a problem if you try to install an application on the Mac and it tries to write to it after the installation's been done.
Correct.
Yeah.
But that's a one-line fix in the code, though. I did it on mine and was able to get it to work.
Now, Eric, have you thought about splitting out to be more traditionally app-shaped into two regions then? A writable and the read-only portion of the app?
Yeah, I might create some, it seems like the Mac users would prefer to put, and probably Linux users would prefer to put the config file in the home directory instead of next to the application. So I can probably make that the default and or put in an environment variable or something like that.
Well, I think you have more issues than just the config file in that when you're writing from programs that you write here and compile, you're writing to next to where the source was. If you're running examples, that's kind of a problem.
Oh, that's true.
In the main app.
Yeah.
So you kind of got to think about all of that and how to organize it. Part of why I'm asking this question is as we're writing tools, for instance, your tools here are the first I'm getting operating on the automatic compile with VS Code. When I'm writing things like that, unless we want every person adapting to where they installed your tool, we should really have conventional install locations. Linux advocates for conventional install, Mac does, everybody does. And so actually configuring it into two parts, writable and not, allows us to then really think of conventional install locations.
Then you need to find the writable part, though. You also need permissions. Like, I see both sides of it. I like the ability to just unzip the file somewhere and have it run. You know, you can put it on a USB stick and carry it around with you.
Agreed. From that aspect, I agree.
Yeah. But the downside is that, yes, that means you probably have multiple, you may end up with multiple installs if you.
Yes. And that's
been Windows would prefer
for a long time. Sorry, Roy, what?
Windows would prefer the split setup too, where you install the app into program files and then store your data into either app data or documents.
Correct. So
which
that's
are
pretty much
writable
all
by
the
the
major
user.
operating systems ask for the same thing now. That's how they get around it.
I just want to jump in here and provide a counterpoint.
Okay.
I've got a bunch of kids, basically 6 of them currently, and what we're doing is we're using the memory stick model. They don't have to make any changes on the machine. They can unzip it, they can put it on a memory stick, they can run the entire thing from the memory stick and not touch anything on the you know, on the PC.
I'm guessing you're with school systems. That sounds like that background.
Yeah.
Yep,
Yeah.
I fully understand that. And yes, it's the right way to secure the machines. Yeah, understood. It sounds like we have to support both models with tools.
I guess ideally we would support both. It's a lot of work, though.
Of course it is. Of course it is. It's also a lot of work documenting how to work in both environments when we don't really naturally work in both environments.
Yeah.
Which one do we want to solve? One, you spread the work out to all the users, and one, we do it as the application developer.
The way it's coded right now, it's literally in the GUI.tcl file. There's one line you got to change that would fix the problem on the Mac and the Linux users. But the Windows user is going to have a couple more lines of code added in there, I think, to make it work.
And you're talking the problem for just the config file, right?
Correct.
Understood.
Yeah, the samples are another can of worms.
Right. Now, what a lot of distributions do for the Mac, I'm not saying this is the right way, it's just a way, is they tend to break out the samples into a separate installable piece. And then you get to choose where you want to put that aside from the application itself.
Yeah.
And not home them under the same tree.
Yeah,
I was who was it that just posted the DMG for the Mac? Thank you, that was wonderful.
That was me. That was me.
Thank you. Good job on that.
And it's modified to put the config file in your home directory.
Nice, nice. And so yeah, let's split out the samples in that too as a separate folder that you can put somewhere in. That just didn't get really clean for the Mac.
Yeah, in order to do that, I don't think you'd be able to do that with a. You could do it with a DMG, but you'd have to have 2 drags in there. Or I think if you built it into a package file, you could script it to where you could drop the samples in the home directory, you know, library, application settings, or wherever it needs to be.
Right. Well, the same is probably true for Windows. An installer would put things in the right place.
Yeah.
Yeah. Anyways, before we talk about how to install bullshit, we should enjoy that Eric does all this stuff, and we should kind of give him a big hug and he is doing a perfect, very good job, and without him we would be lost because I can't install Peanut on my fucking system at all because it gets deleted.
I want to second what you said. Thanks, Eric. We really appreciate it.
It's my pleasure. This is a great community, and I'm glad I can contribute back something.
Yeah. Whenever we're talking and we're trying to sort through these things, sometimes it's hard to remember that we're doing it because we really like what you're doing. We're interested in what you're doing. We want it to work well everywhere.
No, it's good. Actually, constructive feedback is always helpful. I mean, I might not always take it, but it's always good to hear it.
Yeah,
thank you.
That sounds similar to us all.
It's nice to know people are actually using it.
It's better to know that people will send you fixes back rather than just complain.
Yeah, definitely.
Yes.
Definitely.
I
And I'm always
actually
happy to
like
get.
now your basic better than spin because of that file access. It's so easy and it's so nice. I
It
mean,
depends what you're
no,
doing. I mean,
I like
spin.
that basic more like spin right now.
It depends what you're doing. For some things, spin's better. For something, maybe basic's better. For some things, C might be better. I mean, you know, MicroPython's better for some things. It's just.
Hey, Eric.
Mhm.
Did my update, my pull request, make it into the 5.0 release?
The fixes for simple tools?
Yeah, the additions and fixes.
I think so. Yeah.
Okay, just making sure.
Thank you for that, Roy. That's
Yeah.
and actually, yeah, Roy's really contributed a lot. Roy's been porting a whole bunch of code over from the prop GCC libraries to
Thank you,
FlexProp.
Roy.
Simple tools stuff so that you can actually, in a lot of cases, for a simple Blockly prop code, you can save it out and compile it with FlexC now, as long as it doesn't use any special devices that aren't handled by basic simple tools functions.
Yeah, you are doing a great job there, Roy. Also a hug for you.
Yeah.
I don't feel like I've done a super lot compared to how much Eric has done.
We're all contributing. You know, it is
Although
a community, and we all contribute, so it's great.
I do think it might be beneficial to, after I get simple tools more done, to do an Arduino library
And intercept
translation so that a lot of Arduino code will just run by compiling it against that include. Because it's just about implementing things like the digital write, digital low, and a bunch of other basic functions for driving the pins. And then a lot of stuff will just work.
Yeah, and the thinner you can make that, that'd be excellent.
Somebody had done that already on the P1. I don't remember what it was. Was it Catalina or something? Somebody had started pulling in all the Arduino basic libraries.
I'm not sure how far that got.
And now that was with prop GCC and
it was probably related to that one board that had the Arduino layout with a prop one on it that Parallax carried for a short time.
Propware.
What it was called.
Propware is what it was. Propware.
No, I think Propware is something different.
That's something different. That is C++ from David. But on David's Team City server, you also find the Arduino, something like that. Arduino lib, and that basically contains in C a lot, but for the P1, not for the P2.
Right.
Forgive me if somebody's already answered this. Does it do MicroPython too, Py files?
No. At one point I had the MicroPython interpreter in here, but I think that could get confusing, so I took it out. But it was never able to compile. Python's a very funny language, and it really needs to be interpreted rather than compiled. Now I have thought of at some point doing a subset of Python, you know, that's restricted, so you can't do things. Because in Python you can do things like using the same variable for different data types at different times. Like you can put a string into the variable, or you can put a number in, and you don't know until runtime what kind of value is in the variable. If you avoid things like that, it might be possible to compile it.
Please, Eric, don't try to integrate Python. What you should do if you have, for some reason, any spare time, is building your own bytecode interpreter, kind of a CMM mode.
Yeah, well, that would be useful.
I think the Python syntax would be nice to have. I understand the variable issues and all of those, and yeah, they can catch you out real easy. But the actual syntax is very nice, and it's not unlike Spin.
Yeah, we could certainly do a language that had Python syntax, but the semantics would have to be different.
You know, you could.
We don't need that. We have Team Oz doing MicroPython. There is already a Python. We don't need to integrate that in Eric's compiler collection.
Hey, well, you could kind of partially tokenize Python, right, to reduce the runtime burden. You could scan through.
MicroPython does that, but as I say, there's the semantics require you to do a lot of stuff at runtime.
So you
I didn't ask that because I wanted you to do that. I was just asking it because you had mentioned that it ran on the Pi, and that's their favorite language. So
yeah, well, the Pi is Linux, so it's C.
All things GNU.
Yeah, I could certainly. I should probably put together a package for the Raspberry Pi. It looks like a lot of people are using it. I mean, FlexProp will certainly run on a Pi.
Mm-hmm.
So to make a Python interpreter, you have to work all the way at the ASCII level of the source code?
No. It is tokenized, but the tokens are, the bytecode is pretty high level. Like if you tokenize A plus B, the plus operator has to, the bytecode for plus actually has to look up in a table to see at runtime what method to use, because the A and B, it doesn't know at compile time what they are, whether they're strings or integers or whatever.
Oh, I see.
Yeah, all the type being dynamic at runtime makes it very difficult to do anything to compress it. You need a very large runtime for Python.
I see.
Yeah, so the Python bytecode is more compact than the ASCII, but it still has to do a lot of work.
Yeah, I see.
If I can interrupt just for a moment, I have to sign off for another task, and I'm passing host over to Chip. And just want to let everybody know we don't have any topics for next week, but we could definitely use some. So if anybody has anything they want to share, let me know.
Cool. Thank you, Ken.
Thanks, Ken.
Thanks.